Hello everyone and welcome to another MingTech Media tutorial. Today we're going to be discussing the MergeSort algorithm, which is one of the more fundamental algorithms you'll see out there in computer science. And I'm going to go through a brief explanation as well as show you an example in Sketch of how the MergeSort algorithm works and go through that sort of like recursive tree. And then go through a code walkthrough in Java. And FYI, as an aside, most of my video tutorials will have code or code walkthrough examples in Java unless otherwise specified. And as another aside, before you go through this tutorial, I want you to at least be familiar with recursion on a basic level, right? Because the function is recursive, so if you don't understand it, you're kind of going to be lost. So what is MergeSort? I'm going to outline a couple of points about MergeSort and explain them in as briefly as I can and as thoroughly as I can. So first, it's a divide and conquer algorithm. And what that really means is that it breaks down a problem to its smallest part and solves that problem, then continues to solve larger problems until the overarching problem or the original problem is solved. And so back to the idea of recursion. At each recursive step, the problem gets smaller, right? We're breaking down the problem and passing it to a function, which is then added to the stack. So at some point on a stack, it's going to reach the smallest point or the smallest problem, and it's going to solve that problem. And once it solves that problem, it's going to return it to the function, and that function is going to be popped off the stack. And we're like at the top of the stack now because we have all these recursive calls. And it's going to keep on returning these problems to the functions that call them once they're solved until it returned it to the original function that called it. So you're breaking it down into these small, minute parts, solving them, and then returning them to the function that called them. And then you keep returning until you get to the original function that called it. Okay. So it runs in terms of time complexity, it runs in O of n log n in all cases, right? So what that means is, so the log n part, that, if you're familiar with logarithms and time complexities, which you should, that's another thing you should be familiar with, is just time complexities in general. And I'll explain this in my analysis video of MergeSort in deeper detail. But what this really means is, every level you break down, since you're having the array input size, that is log n. And I'm not going to explain why that's log n, just it's log n. And like I said, in the analysis video, I'll explain, but you should be familiar with time complexities as a whole before you dive into just other algorithms like MergeSort, Quicksort, and all that stuff. So it breaks down these this array in half, and when you're having something at every level, that is a log n time complexity, and on each level it does linear or iterative work, and that's where you get the n. So you multiply that times log n and you get n log n, and that's why it runs in O of n log n time, and it does this in all cases, best, worst, average, right? Next, what we have is the stability of MergeSort. And it's a stable sorting algorithm. What that means is it preserves the order of duplicates. So if you have an array or some input that has duplicates, it preserves the order in which it sees those duplicates. So if you have 2 3s, and 1 3 is, at the beginning of the list, and another is at the middle of the list, the one that's in the beginning of the list will be in its sorted order first before you have the one that's in the middle of the list. Unlike Quicksort, which isn't stable, and whatever 3 it sees first, it's going to sort that, and then that's the end of that. So it's a stable sorting algorithm, and all that means is like it preserves the order of duplicates. Merge method. The merge method has the bulk of the logic, and that's pretty self-explanatory. There's only really 2 methods to Quicksort, which is the sort method, which recursively breaks everything down, and the merge method, which merges those broken down parts into sorted arrays. And most of the logic is in the merge method. It's not an in-place sorting algorithm. What does that mean? In place means that it doesn't need extra space to do work. Well, MergeSort does need extra space to do work. It needs auxiliary space to do the merge. So it's not in place. It can't be in place. Unlike Quicksort, which is in place, It uses pointers to kind of rearrange and do swaps, which I have outlined in my quick sort video. Check it out. So yeah, that just means it's not in place since it's using extra space to sort these arrays. That would mean it's not in place. So space complexity. The space complexity really depends on the size of the array. Therefore, it's O of n. So if you have a huge array, it's gonna need to break it down a lot more than a smaller array, and it's gonna allocate more extra space to do the merge than it would a smaller array. So therefore, the space complexity depends on the size of your array. So it runs an O of n space complexity, or O of n time for space complexity. So implementation in the real world. So in the case of Java, and it's like this with many other programming languages like Python and JavaScript and C++, and they have their sort functions, right? And it's used, MergeSort is used to sort objects that have varying identities, like seen in collections.sort in Java. What does that mean? Well, two sorting algorithms that you see in Java are arrays.sort and collections.sort. And arrays.sort works on primitives, and primitives really don't have any identity. What that means is it really doesn't have any varying other data attached to it that could make it different, even though some properties on it, like in an object, you have all these properties and methods. So let's just say, like, for an object, you have a name property, right? And you're sorting on that name property, and you have two objects who have a name property of Tim. So MergeSort does is it basically, because you have some objects which may be deemed as equal according to the equals implementation or provided by the comparator. So, that may change the order in which they're seen. So back to this idea of, stability, because MergeSort is a stable sorting algorithm, it makes it better for sorting objects. And scalability. What that means is pretty self-explanatory. As the object scales, or as we have larger input, it scales really well with, doing the work on that input. So if you have a larger input array, it would work better as opposed to other sorting algorithms. So it just scales really large with inputs, or scales really well with larger inputs. Okay, so I'm going to go into Sketch and I'm going to break down how MergeSort really works at each level, and go through that sort of recursive tree and what happens at each level. So yeah, join me for that. Welcome back, guys. Don't be overwhelmed by this. This is just a diagram of the whole MergeSort process. I feel like it would be very beneficial and helpful to you, so you can understand what's happening at each level and how MergeSort breaks down an array, recurses on each side, and breaks down that array into its most minute part and merges it back into sorted subarrays, and merges it back from these subarrays to, or these sorted subarrays, to the final sorted array, right? So one thing to note here, like I said before, you should be familiar with recursion at least a basic level, because you're going to break into the sorting code, and the actual MergeSort code is recursive, right? And the base case is going to be if the left is less than right? So basically, if the left is less than right, if that's true, we break into the code. If it's false, we don't. If this base case is false, if left isn't less than the R, meaning the left boundaries and the right boundaries haven't crossed each other, or the left and right boundaries aren't the same element, what we do is we break into the code and we find the midpoint. And how do we calculate the midpoint? So I'm going to have M, I'm going to denote that as the midpoint, and we're going to have L plus R minus L, and that's going to be divided by 2, and that's how you calculate the midpoint, right? Cool. So after that midpoint is calculated, we're going to recurse on the left and on the right. And we're basically using the midpoint to sort of as a sort of boundaries for the left and the right. So we pass, oops. I'm just going to say MSort for brevity. We pass it our input array and left and the mid. And then we're going to recurse on the right side. And we're going to pass it our array. And we're going to pass it mid plus 1 because we're trying to do the right side. So this is everything from 0 to the middle. This is from the element right after the middle to the end, to R. Right? And then after all that, we're going to merge. After it fully breaks everything down into one element arrays, we're going to merge everything together, and that's going to be the array, the L, the M, the middle, and the right, and that's what's going to take in, right? So how does that happen here in this diagram? So basically, we break into the code. We see that the L here, and we're going to denote the L here, and the R here, right? So that L is array 0, and this is array length n minus 1. So we're gonna do that math, and since this is 6th element, this is the 6th element here. I'm gonna write 6, and this is the 0th element here, 0. Actually, let's make those another color. I think I can just make it like a, oh boy. Let's make this another color. This is a 6th element, and it's the 0th element. So it's going to be do the 6 minus, it's going to do the 6 minus 0 plus the 0 all over 2, and that's going to be 3. So this is basically where we're going to bisect the initial array. And I'm going to do some dotted lines here. All right. So we're going to recurse all the way on the left before coming back to the right and then merging the two subarrays. So we have a subarray here, which is 8149, and then we're going to do that same math to calculate the midpoint, right? So that's going to be 0, 1, 2, 3, 3 minus 0 plus 0 all over 2. That's going to be 1.5. And you know this is programming, so we take the floor values of decimal numbers, right? Unless we are using a float. So you take the floor value of that, that's 1. So 0, 1, that's our next split. So that's the third step here, right? And the L is less than the R. So what we're going to do is we're going to split again. And we're going to split this by calculating 0, 1 divided, or 1 minus 0 plus 0 divided by 2. That's going to give you 0.5. And like I said, we floor that, and that's the 0th element. And so that will be your start and your mid. So we split, there goes another split. That's the 4th step, and it's the 5th step, splitting the other array. And then we merge these two. We merge these two, and 1 obviously is less than the 8. So what happens is we have a counter or a pointer I. We have a pointer I, we have another pointer J, right? And K is going to point to the first element in the subarray and the auxiliary subarray. And the auxiliary subarray, we get the size of that by basically adding the sizes of these two subarrays, right? The left and the right. And we compare these two elements, right? And whichever one is smaller, we add that to the auxiliary array and then increment the array in which the value was smaller, and then continue to compare it to the other array whose value was actually larger until we have a place for all the elements in the auxiliary array. And if there's remaining elements left over, like let's say one array is in an even split and it's like 5 elements here and then 3 elements here, well, the rest of those other elements will go through a while loop and recursively add that, or not recursively, well, just iteratively add every extra element or append every extra element to the end of the auxiliary array. So we break out of this left-hand side of this subarray. So this subarray here. Now we're on the right side of the subarray. We have 4 and 9. We split again, and it's the 8th and 9th step. And after these splits again, we merge at the 10th step, right? And this is the overall left-hand side of the input array. We're still on the left-hand side. We haven't even touched the right-hand side yet. Remember what I said, you have to recurse all the way on the left before coming up and recursing on each right-hand side. So we're going to merge these two subarrays, and similar to these subarrays, we have a counter I and then a J, and then a auxiliary array which has a pointer, not counter, sorry, a pointer, and it's going to point to the first element of all these arrays, this subarray here, and that subarray, and we're going to iterate through and basically find which element is smaller, and we're going to add that to the output auxiliary array. Right, and we're going to go through these. We're going to say 1 and 4, which one is smaller? 1 is smaller, so we add the 1. And then we iterate the I, right? We're going to compare 8 and 4, which one is smaller? 4 is smaller. So we iterate the J, right? We put the 4 here, we iterate the J, and all while K is still being iterated. And K is going to be iterated no matter whether the I is smaller or the J is smaller. Whichever one happens, the K is still iterated, because you need to progress through the auxiliary array and find places for each one of the elements that are being pointed to by the pointer, right? So we're going to go through this, and we're going to do our comparisons, and this is going to be a sorted subarray, and then we're going to recurse on the right-hand side. So we're going to split, and on this right-hand side, we're going to go left first. So this is going to be the 13th step. We're going to split the 3 and the 11 into subarrays, and these are sorted, so we merge these two, right? And then we're going to go recursively on the right-hand side, and since there's only one element, this is just merged. This one element array is merged with this 2 element array, which is sorted. So we get this sorted subarray, 3, 11, and 15. So now we have 2 sorted subarrays, which originated from this overall array here. So what happens next is, like I said before, you have a counter, a pointer. I keep getting those mixed up. Sorry, guys. So you have a pointer J, and then you have a pointer I, and then you have a pointer K, which points to the first element of all these subarrays. So I points to the first element of the subarray on the left-hand side, J points to the first element on the subarray on the right-hand side, and K points to the auxiliary array, which has been created and allocated by using the sizes of these 2 subarrays together to create this. So we do our comparisons. We compare 1 and 3. 1 is smaller, so we add that to array K. We iterate I, and we iterate K, and we compare 3 and 4. 3 is smaller, so we add RJ to array K, and we iterate J, and then we iterate K, and so on and so forth until we add all the elements to this array, and the array turns to be sorted. So that's the last step. So this is basically how the merge sort algorithm works. It works by breaking every subarray into its most minute part, which is a 1 element array, and then merging these 1 element arrays and merging these subarrays up until you have your sorted array here. So this is all sorted, right? This is sorted. And that's basically a diagrammatic representation of how MergeSort works. And now we're going to break into some Java code and see how to code all of this up and code up all this logic. All right, let's get to it. All right, guys, how's it going? We're back, and I'm in here in my Eclipse, and I've created a class in my algorithms package. And the class is called MergeSort, and I have my main method here. But before we do the main method, like I mentioned earlier, the bulk of the logic is in the merge method. So what does the merge method look like, actually? So the merge method, the signature, it's going to take in a few things, 4 things actually. It's going to take in your array. You're going to take in your low, your mid, and your high, right? So it's going to look like this. Oops, sorry. This is going to look like, sorry about that. So like I said, your array, your low, int mid, and int high. So that's like your basic method signature, right? So what do we do first in this merge method? Like I said, the first thing you want to do is you want to find the length of the subarrays. So find the length of subarrays. All right. So how do we do that? So the best way to do that is to subtract. Well, for the left side, what you need to do is you need to subtract the low from the mid. So look like this, and len, I'm gonna say len 1 equals to mid minus low, and we're gonna do mid minus low plus 1. Now, why are we doing mid minus low plus 1? In programming, as you know, the first index starts at 0, right? So let's just say our mid was at the 4th element or the 4th index, and we did mid minus low, which would be 4 minus 0, that'd be 4. But that wouldn't be correct because there's actually 5 elements. 0 is just like natural numbers, counting numbers within actual mathematics. But in programming, the 0 actually has the 0th index actually has a value in it, So we have to account for that offset because we're doing mathematics, but then we're in programming. So we have to account for the actual 0th index, which actually contains a value. So if it's 4 minus 0, that will give you 4 in just general math. But in programming, since we started 0, it has to be 5. So from the 0th index to the 4th index, that's 5 numbers. That's 5 elements. So we have to account for that by adding the plus 1, just to explain that. And then we're gonna have inlen 2, and that's gonna be equals to the high minus mid, right? So after that, what do we need to do? We need to create temporary arrays. So let's say create temp arrays, and we're going to use the lengths that we just created. So we're going to create our arrays, and I'm going to name this left, right? And that's going to equal to new int and len 1, right? And I'm just going to copy this, and then I'm going to bring it down and name this right and len 2. All right, so we create our temp arrays. Now we have to copy the data to the temporary arrays, and for that we're going to need 2 for loops, right? So copy data to temp arrays. So what we're going to do is we're going to use 2 for loops. So we're going to say int I is equals to 0, I is less than, what is it, len 1, and plus I. And so we're going to have left I, and that's going to be equals to array I plus 1. And again, with the offsets, why are we doing this plus 1? So for every index at I, we are going to okay, let's just go through this here. So the first index is going to be 0, and 0 plus 1. What is that gonna leave us? Oh, sorry. I'm sorry. This is supposed to be low plus I. Sorry. So the low is going to start at 0 plus I, which starts at 0. So it's going to be 0 plus 0, which is 0. So, that first index 0 is going to be equal to the first index at the array 0. Then, as this I grows, because we're iterating it, as it grows, it's going to be 0 plus whatever I is. So 0 plus 1, the next iteration, 0 plus 2, the iteration after that, and then 3 after that, and so on and so forth, right? So we just want to make sure we always start from 0 and offset it with the I value, whatever I is right now, right? And it's going to be similar, it's going to be similar for, for the J value that I'm going to create, or for us starting from, so this is basically us iterating through, so this line right here, these two lines, 15 and 16, this is us iterating through the original array, and everything on the left side, we're adding it to the left array. So we're going to similarly do that for the right side. So int j is equal to 0, j is less than len2 plus j. So what's going on here? All right, what is j is less than len2? Trying to figure out why there's an error. What is it saying? Not sure why that error is there. Maybe because I haven't typed anything here. So, right, j is going to be equals to array, and we're going to just add the mid plus 1, and again, we want to start from the element immediately after the middle element, and also we're going to offset it by adding the j, whatever j is right at that instant. So, all right, we're done copying the data to the temporary arrays. We've done that. The next thing that we have to do is we have to merge these temporaries, right? So next step will be merge temporaries. And so what we're going to do is we need a couple of, counter variables, or iterator pointer variables, I'm sorry. So what we're going to do is going to do int I is equals to 0, comma, because we need another one for the other array. So we need two pointers, int I and int j, right? And then we're going to have we need an index for, let me see, the initial index for merge subarray. So what we're going to do is we're going to have an int k, and we're going to set that equals to low. Now here's the fun part. We're going to have a while loop, right? And that while loop is going to run as long as I is less than len1. Let me spell that right. len1. And j is less than len2. We need two ampersands there. All right, there we go. So it's going to run from as long as, let me just give this a little bit of space, I is less than len1 and j is less than len2. So let's break into this while loop and see what we can do. So we're going to have an if condition first, right? And the if condition is going to state as long as the left I is less than or equals to the right j, what are we going to do? Well, we want to add whatever is in that to array k. So if this condition holds true, the condition on line 27 holds true, then what we want to do is for array k, we want to set that equal to that left I, right? And then afterwards, we want to iterate the I. Now, if this is not true, what we want to do is we want to have an else condition because if it's not true, there's only other one condition. Like if it's not less than or equals to rj, that means rj is greater than it, and we're trying to put the smaller value in that first array k element. So what we're going to do is we're going to set array k is equals to left I, and that's it really. And after that we gotta iterate the j, right? And after that so before we break out of this while loop, we want to iterate the k, because the k is going to be our auxiliary array. It's like our space it's like our array that we store the merged result in. I spelled initial wrong. So k is going to be incremented no matter what, because we got to progress through the resulting array, right? And since we know, right, since we know that this like arrays, or these arrays that we are sorting, might not be of the same lengths, like the left array might be bigger than the right array, or vice versa, the right array might be bigger than the left array. We need two while loops to account for that. So the first while loop is going to say while I is less than len1, what do we want to do? We want to store whatever. We're going to take array k and store whatever's in left I, and then we're going to iterate I, and we're going to iterate k. So I plus plus, k plus plus. And you're basically going to do the same thing, but with the left array. So I'm just going to copy this and then go down and paste, and then change this to j, change this to 2, change this to right, change this to j. All right. So this just accounts for if the right array is bigger, and this accounts for the left array being bigger, right? So that's basically our merge method. Like I said, the bulk of the logic was in this method. And just to recap, I'm going to run through it real quick before coding out the rest of this merge sort algorithm. So like I said, in the merge method, you want to find the length of your two subarrays. Remember the offsets here, what I talked about. Well, this is just one offset, not offsets. And that's because, low would be 0. So if you had a number like 5 and minus 0, it's going to be 5. But there's actually 6 elements from the 0th element to the 5th element. So we have to add that plus 1, FYI. Then we create our temporary arrays. And then what we do is we allocate the space in them to be these lengths. The length for the left and the length for the right. And then we copy the data in the left and the right into our two temporary arrays. And then we create some pointer values. We create some pointer variables with I and j, and then we set them equal to 0. And then we create a pointer k, and we set that equals to whatever the low is, right? And that's going to just be used for the initial index of the merge subarray. Then we're going to have a while loop that checks to see, whether I is less than the length 1 and j is less than length 2, i.e. the left and the right size arrays. And then once we break into that while loop, we're going to have an if condition that checks whether the left I is less than the right j. And if it is, we throw that into array k and we iterate I. If it's not, we throw the left I. This is supposed to be right. Good thing I went over it. And it's supposed to be j. So we throw the, sorry for confusing you if you were like coding along or writing along, but this is why we go through things. We go through things to check to see for their correctness. So the array k, we throw the right j in there, and then we iterate j, and then k gets incremented no matter what, because you need to progress through the resulting array, and we need to, or the merged array, the array that you're merging into, we need to iterate through that no matter what. Just whatever is put in that just depends on what's in the left I and what's in the right j. So we have to do our comparisons. Then we have our two while loops that account for the left side and the right side to see whether, if there's remaining elements on the left or remaining elements on the right, because some of these arrays might not be the same size. So we need to see whether we have remaining elements, and if we do, we copy them into the merged array. So that's basically how the merge method works, and that's where the bulk of the logic in that method is, or in, MergeSort algorithm is. So what I want to do is I want to create the actual recursive function, recursive method that breaks down the array and sort of partitions it, not really partitions, but breaks it down into its minute parts, and then we call the merge method to merge those parts together. So what is that going to look like? It's going to be public static, spell static right, void, and I'm going to say sort, and basically I'm going to take an int array, I'm going to int low and int high. Those are going to be our three parameters. That's going to be our three method parameters. And what we want to first do is we want to check to see if low is less than high. What that means is that just means if there's no singular element in the array, because if it's a single element, the low is going to be equal to the high, or those boundaries just haven't really been crossed. So if that's true, we want to break into this if block, right? First thing we're going to do is we're going to create a middle variable, and we're going to set that equals to low plus the high, and then we're going to divide that by 2. So, and I'm going to just do a couple code comments. Let's see, find mid. So the next thing we got to do is we got to sort the first and the second half. So sort both left and right. So how do we do that? We just do sort. So from the left, it's going to be, remember, we take an array. It's going to be low to the mid. Then sort. We take an array, and it's going to be mid plus 1 as the first element that we start from to the high. So you see how it divides these subarrays into two different halves, the left and the right half. Once we find that middle element, we can do that. And once we have the mid, we can sort of bisect that array from the low to the mid, and then from the mid plus 1 to high. So it's how we just recursively break that array down. Next, we need to merge these arrays. Merge sorted halves. And remember, like I said, an array with one singular element or an empty element, an empty array, is going to be sorted by default. If you're the only one in line, you're the only one in line, and you're the first, so you're sorted. So what we're going to do is we're going to merge the array, the low, the mid, and the high. And that's basically it. That's basically it for our MergeSort method. And what I want to do is I kind of just want to print out what we have. Like I want to test this out. Like I want to have like a little test sort of case kind of thing. So I want to print out I want to create a method to print this out, to print out, the array. So make sure I'm out of that, and public. So what I'm going to do is I'm going to create a method called print array. And what I'm going to do is it's going to take in whatever the int array that you're working with, And for it, inside this, I want to just find a length first. Equals array dot length. It's loading. Okay, there we go. Array dot length. And just as an aside, we don't do that for an array, right? I used to confuse me whether to put whether it's size or length. Size is for like array list, and you would include the parentheses after that because it's a method that finds the size of an array list. But for arrays in Java, what you do, it's a property, or the length is a property on that array. So it's you can just do dot length. It's not a method. So yeah, that just tripped me out. So I just thought I'd add that in there, especially for newer or more intermediate programmers. So we all look up stuff, even senior engineers. So I'm gonna have a for loop, and it's gonna iterate through the array with that length. So we're gonna do int I is equals to 0, I is less than what is the len, and plus I. So basically, what we're gonna do here, once we're iterating through array, we're gonna print out each value. So I'm gonna do sysout. What is this? Print line. So we're gonna print out the array, and we're gonna concatenate a space. So after that happens, we're gonna need a line break. So I'm gonna do system out that print line. So I'm just gonna copy this. Copy this. It's taking so long. All right, there we go. And let me add these parentheses. So we're done with our print array method. So what do we do in our main method? And this is the last portion here, and then we can test this out and see how this works. So basically, let's just declare some sort of array with some values. Int array. I'm gonna say 2, 7, 9, 11, 10, 7 again, 3, 1. There we go. That's our array. So what we're gonna do, we're gonna call MergeSort. We're gonna create some sort of object here. Let's just print out this array first. Let's print out this array. So we're gonna need this. So we're gonna say array input given. That, and we're going to call print array. And then we're going to pass it the array. So it's going to print out the array first, the raw unsorted array. And the next thing we're going to need to do is we're going to need to create a MergeSort object. So MergeSort, I'm going to just name this MS equals new MergeSort. And then what we're going to do is in ms.sort, and we have our array. Low is going to be 0. High is going to be array.length minus 1. Minus 1. Because we're trying to get that last index. And then we do something like this. We got to print out the sorted version of the array. So I'm gonna do a couple space lines here, and then I'm gonna say sorted output. Sorted output. And we're gonna do that print array again and see what we get. So now basically in this main method, I create an array, and then, you know, we have a print statement that says the input given, and then we just print out this raw unsorted array. Then we create a MergeSort object, and then we pass the MergeSort object. We call the sort on the MergeSort object, this sort up here, and we pass it our values, the array, the starting value, which is the low, and the high, which is array length -1. And then we have some other message here, sorted output given, and then we print out the array again with our print array method. So let's run this and see what we get. Okay. Exception out of bounds. We got an out of bounds exception. Trying to figure out what the problem is. Usually when there's an out of bounds exception, there's like some sort of trying to figure this out. Bear with me. Did that right? Did that. There might be something up here that wasn't done right. I think I got it. That's probably what it was. Let me try that. All right, there we go. Actually, I think I just want to do a print, not a print line. All right, let's do that. See how that works, because I want everything to be on the same line, just so you can see. So yeah, I messed up the formatting, but you can kind of see that it's sorted. Let's just fix this formatting really quick. So instead of a print, let's run that. Okay, there we go. So yeah, I'm glad I actually had those errors in there. So, you know, because it kind of just shows you how to debug. Because I had an array out of bounds exception, so I knew something had to be wrong with where I was doing loops, or just where, I guess, something had to be wrong with like one of my variables. And I found that up here, like on line 44, instead of the I had the J. And hopefully you caught that quicker than I did, because I'm kind of just typing and explaining. I've got this mic in my face, so, you know, it's not how I like in my natural element. But, you know, we were able to solve this problem. We're able to get the correct answer. You know, sometimes I like videos, well, at least when I'm teaching or I'm learning online, I like videos where the instructor kind of makes a mistake, because when you're in the wild and when you're a programmer at a company or so, you need to know how to debug. That's one of the main skills that any software engineer needs to have. So I hope I was able to show you how, at least, to find an array out of bounds exception if you ever come across it in the wild. Look at your loops, see what your variables and your counter your counter or pointer variables might be, and where they're stopping, and making sure that they're all consistent. Because you might have an I in one place and a J in another place, and then the computer is following your instructions and it doesn't know what to do, and it sends you this exception. That's just a good example of like how to debug and how to code and things like that. But now let's get back to our actual output. So we had in our array, this is 2, 7, 9, 11, 10, 7, 3, and 1. As reflected here, that's our array input, and then our sorted output given, we have 1, 2, 3, 7, 7, 9, 10, 11. So yeah, this merge sort code works, and in this, I hope I was able to explain this, thoroughly, in a way that's clear, concise, in a way that you can understand. Remember, this is an O of n log n algorithm in all cases, in best, worst, average case. Also, to note about MergeSort, it is not an in-place algorithm. It needs to allocate more additional auxiliary space to complete its sorting task. However, it is a stable algorithm, so the duplicates which it does see, it prints those out, or it sorts those in the order in which they see it. So since it saw the 7 first, and it's like the 7 appears first, it would be sorted in that order first. And I know we can't really see it here, but if there was a way we could like annotate it or so under the hood, or like, and just show you sequentially each step, you'd see that it is stable, and that this 7, which was here first, this 7 right here, is the one that appears first. Again, I know you can't really see it. There's no way to really see it, but understanding what MergeSort actually does and how it's stable under the hood will lend you well to understanding how these things are sorted, and how it sorts the things that it sees first, the duplicates that it sees first. So yeah, this is the MergeSort video. I don't want to ramble, I don't want to rant, but I hope you are able to understand this, and understand this in a way that best fits you. Again, like, these videos are going to be all in Java. And like, comment, and subscribe for more content. I should have a quick sort video coming soon if it's not already up there. And yeah, you have a nice day, and I hope this is able to help you. Keep coding, friends.